Because like I said, each of those laws, there are there are areas you must apply them. Let's take, for instance, you are going for an exam, maybe that you do maths and you see maths question. Any question that you see under that maths, there are principles, laws that guide them. You can name it anything, be it principle, but I know there are foundations that guides them. So one of that foundation is what I am treating, which is law of indices. This shows that for you to understand maths very well, generally for you to be versatile in mathematics, you must know law of indices. You must be very familiar with every detail under laws of indices. So we'll now go to our first question. So let's take, for instance, now, as a normal average mathematician, you stumble into something like this. You normally, if you are not too familiar with any of those laws regarding mathematics or any of those foundations regarding mathematics, you will see this as a very big and difficult question. That is why a lot of people shy away from maths, because you see a lot of numbers, variables, this, blah, 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 mixed up together. You will not know where to start from. But I bet you, when you have good knowledge of all these principles, you will know where to start your maths from and know where to end your maths from. So when you see something like this, automatically, this is telling you that to solve this, you must apply law of indices. So the first particular variable is a raised to the power m divided by a raised to the power n times a raised to the power b. Here we are applying the first law and the second law of indices. Here this explains the first law, an times ab, which states that when two indices, this is how it looks like. We are now analyzing this 6x raised to the power 2 and also b divided by 2x raised to the power 3 and also c. We'll now solve it this way. Why is it now in form of fraction now is that we are applying this. A divided by b is still like this. Still the same thing, still the same thing as a all over b. Still they are the same thing. A divided by b. It can be 2 divided by 1. That is 2 divided by 1. So that's all we have. This divide by this. So we give you, that is this whole indices divide by all over this whole indices. So here we now divide. This 2 here is 1. This 2 here is 3. So we now have 3x square and also b divided by x cube, that is s cube according to the equation, s cube cubic s cubic raised to the power C also. X raised to the power 3, sorry, not cubic, x raised to the power 3, and also raised to the power C. So we can still simplify this further, like this. You now have 3x squared times b. Here we have applied the 25 raised to the power is still the same thing as the square root of 25, which is equal to 5. So example C is 8 raised to the power 3. Now you can see the denominator. So this will be give you that is the third example. Says 8 raised to the power 1 all over 3, which will give you the cube root of 8, which is 2. The cube root of 8 is 2. Then example D, that is 8 raised to the power 2 all over 3. So now, like I said, this is still the sixth law of indices, that when you have a fraction like this, here you find the root of the root, you make that indices, the denominator, the root of the indices being the variable, then the numerator will be the power. That is, the denominator now will become the root, that is the cube root of 8. Then 2 will now be the power. Why we don't make this, we can still solve this the previous this thing like this, raised to the power 1, but it's still the same thing as writing it normal. But mathematically, this is how it's supposed to be, because 1 now will be the power because it is the numerator. So we are applying that here. So 2 now becomes the power because 2 is the numerator. So now we will solve it like this. The cube root of 8 is 2. You can see, which is 2 raised to the power 2. Then 2 squared is 2 times 2, which is equal to 4. You can see. This girl. What is so? You can see. So since we have bring the numbers, the indices together, and the numbers are identical, here we can apply the first law of indices. So we now have 2 plus 2 plus 1. So we now have 2 raised to the power 4 plus 1. So this is our answer. Okay, we will now simplify this. Example 1, simplify 16 raised to the power 2 all over 4. Divide 8 raised to the power 1 all over 3 plus 37 all over 2 raised to the power 0. Example 2. Solve this. 9 raised to the power 2 all over 3 plus 6 raised to the power minus 2 plus 5 raised to the power 2 divide 7 raised to the power 0. So, example 1. 16, 2 all over 4, 8, 1 all over 3 plus 37 all over 2 raised to the power 0. Here we apply the sixth law of indices. Here we also apply the sixth law of indices. Here, like I said earlier, anything raised to the power 0 is 1. That is the fourth law of indices. The fourth root of 16 is 2. To remove the square root sign, we find the fourth root of 16, which is 2. Raised to the power 2, divide the cube root of 8. To remove the square root sign, you find the cube root of 8. The cube root of 8 is 2 plus 1. Then we have 2 raised to the power 2 is 4. Here, so here we apply the law of indices. Divide is still the same thing as 4 minus 2 plus 1, which will give us 2 plus 1, which is equal to 3. We'll now go to solution number 2. 9 9 raised to the power 2 over 3 plus 6 raised to the power minus 2 plus 5 raised to the power 2 divide divide 7 raised to the power 0. So, you can see the equation. Now, we find the cube root